Hi, so today I'm going to be going through how to approach a Biology CIE AS Paper 3. I have done this first paper on my YouTube channel, so you can check out the full walkthrough for that, but I will also be going through a few questions from other papers. However, this video will not be covering everything that you may come across in a Paper 3, so just be mindful of that. To start off, whenever you are introduced to an investigation, it would be quite ideal if you are to highlight your independent and dependent variables, because it is likely that you are going to be asked to produce a table. And these are actually really easy marks, because by just identifying the two, you already have your headings. The independent variable is always the variable that you are changing. The dependent variable is the result that you obtain. So for this first part, we're doing a serial dilution. And basically, they want us to reduce our original solution by a factor of 10 each time. Okay, so they obviously give you this diagram, and then in red is the working out for it. If we have been told to reduce the concentration of a solution by 10 each time, that must mean that we are dividing by 10 each time. So as you can see, the decimal place moves once to the left each time. That would give you 1 mark, as long as you've at least mentioned the units once. So moles per decimeters cubed. I have abbreviated it with capital M, but ideally you should use moles per decimeters cubed each time. The second mark is for transferring 1 centimeters cubed of the previous solution to the following solution. And then the third mark would be to add 9 centimeters cubed of distilled water to make up our 10 centimeters cubed. So basically, throughout the procedure, we need to maintain a volume of 10 centimeters cubed. 1 centimeters cubed would be of the previous solution, our previous concentration, and the remaining 9 centimeters cubed would be water to make up that 10 centimeters cubed. The reason we're transferring 1 centimeters cubed is because we're trying to make the next solution 1/10 concentration of the 10 centimeters cubed, 1/10 the concentration of the previous solution. So 1 out of 10 is our previous solution, and 9 out of 10 is our water. Therefore, we have 1/10 the concentration of the previous solution. Okie dokie. So, like I said, it is important to determine what is your independent and what is your dependent. Like, we've found that our independent variable is the concentration of hydrochloric acid. Our dependent variable is our diffusion distance. And as you should expect, they've asked us to produce a table. So they've also specified that throughout the experiment, they want us to record at 10 minutes and at 20 minutes as well. So just be mindful that a table doesn't have to necessarily have 2 column headings. It could have 2, and then one can have 2 subheadings, okay? So to gain the marks for this, because it is a 6 marker, and usually tables are 4 marks, worth 4 marks, but that depends. So in this case, there's more work that needs to be done. So the first mark would be for your heading, for your independent variable, and no units in the body of the table. So your units have to be in your headings and not in the body, so not next to the values. The second mark would be the heading for the dependent variable, as well as the units, and no units being in the body of the table. So it's mark 1, mark 2. Our third mark was for our measurements at 10 minutes and 20 minutes, so these values. And then our fourth mark is for accuracy, so our highest concentration aligning with or not necessarily the values themselves, but for example, the diffusion distance recorded for the highest concentration being longer for the diffusion distance for the lowest concentration. And a few more detailed points that you should be able to obtain. Also, another thing is your values have to be to the nearest millimeters. That is dependent on the tool that you are using, the device you're using to measure. Usually rulers can only measure to the nearest millimeters, so any decimal points prove that you're not actually being accurate with your results, because technically you'd be making them up and your tool is not designed to be that accurate. And then the 6th mark is for also accuracy points with the values you have produced. Also, a lot of questions ask you about the sources of errors throughout experiments. These are stuff that can be really basic. At times it might require a bit of thinking, but usually it's as simple as it being difficult to measure the diffusion distance. Because, for example, let's say if a dye is being used, the dye is pale, or whatever the reasoning may be. Then here's a calculation question they might ask alongside your table, but in this case it's not really a calculation, it's an estimate. So they said use your results at 20 minutes, this is our 20 minutes, to estimate a concentration of hydrochloric acid in U. So they've given us a U value, I just put it into the table, and their results were 7 and 11, okay? We are trying to find the concentration of whatever U of the solution U, but we don't know the concentration. So what we've done in this experiment is we've produced serial dilutions to estimate whereabouts our concentration is. So if we look, we have after 20 minutes it's 11, and obviously none of the other concentrations have 11, but we have one value below and the nearest value above, 9 and 14. So it lies somewhere between 0.2 and 0.02. So I can just go for example, 0.1. Anything between these two would give you the mark. But if I feel like, for example, my value is closer to 0.2, I wouldn't go for a 0.04, for example, okay? Then obviously you do have improvement questions. These are just things you need to be familiar with. So going through question papers, mark schemes really quickly, or honestly sometimes it could just be logical thinking. Things like repeat and calculate a mean are really easy. This sort of answer can be used in most questions, and then more concentrations in this case. Then it asked us to calculate the rate of diffusion over 20 minutes for the 2 moles per decimeter cubed hydrochloric acid. This is our 2 moles. I've just randomly put this in for the sake of this calculation question, but ideally when you're making your tables, try to make it so that there's a trend. So for example, concentrations, you can do them in decreasing concentrations or increasing. So this 2, ideally I put it up here rather than down here, but this is just for the sake of explaining. So it says the rate after 20 minutes, and we have 18 millimeters for 2 moles per decimeters cube. So 18 millimeters, they've asked for over 20, so we've provided that. Our units matter because 18 is in millimeters, 20 is in minutes. If we divide 18 by 20, we get 0.9. Therefore, our units are millimeters per minute. So that would just be our answer for that. And yeah, so ideally your measurement divided by 20 would give you 1 mark, and then the second mark would be your correct answer with the correct units. Okie dokie. Down here we have a second experiment where they have produced a table for us and they want us to graph it. This graph is not accurate. I simply mimic the shape of things, but really this is just for explanation purposes. So there are things I have not included prior to this. 1BI, okie dokie. So first of all, you get 1 mark for your x-axis. So usually your independent variable comes first, and then your dependent variable comes second. So this is your x, this is your y-axis. So x-axis, you need to do temperature in degrees Celsius, and then y-axis would be percentage transmission of light, but you'd write percentage in full, and then you'd use its unit, which is percentage. These 2 labeled axes with their units give you a mark. Technically, you don't even have to include this unit because it is percentage. It's been stated in the name, but it doesn't hurt to do so. Then the second mark is for using a suitable scale. In other words, So you can't have a labeled axis at more than 2 centimeters. So I think this would be 2 centimeters. So you can't start here, for example. That's what I think they're trying to say here. And of course you get a mark for correctly plotting all 5 points using either dots or crosses. I find crosses are more convenient. And then 5 plots joined with a line passing through all the points gives you the mark. No extrapolating like so, just going through the points and connecting them. You should be familiar with what sort of graph you are to be producing. So does it look like the line that you're expecting, or does it look like the curve that you are expecting? With rates, it's usually a curve, for example, because when your concentrations of reactants decrease, so does the rate, so you won't get a straight line. Unless something is in excess, for example. Then when it comes to drawings, because they do make you draw, okay, so this one is worth 5 marks. Now, the marks for this one being you have it to an appropriate size. So let's say your paper is this big, your drawing can't be this small. It has to take up a significant amount of the page. So the second mark for this would be to also no shading. You shouldn't be shading whatsoever. You should just be drawing continuous lines. But yeah, the second mark would be for drawing the correct section of the leaf. They've specified up here what region they want you to draw. So make sure you know exactly whereabouts they're talking before you start drawing. It's also asked for the third mark being drawing at least 3 vascular bundles in a line and no cells drawn. So these are my 3, and no cells drawn meaning no like small circles inside. This is usually because either it's not to this, it's not the resolution of the image not being high enough. But also, they usually, if they want detail, they will, like, for example, down here, they will ask of you to draw 2 adjacent cells, for example. And then the circles being the vascular bundles for the 4th mark. And the 5th mark is the mark where they have asked us to label and identify the epidermis. When you're labeling stuff, try to make shortcuts, as in don't try to go through the whole of the cross section to label epidermis. Try to reduce the amount of overlapping that you do when you're labeling. Now I'm just going to do a few more questions from the May-June 2023 paper 31 CIE-AS biology paper. So again, highlight your independent, dependent variables, independent being the effective pH, dependent being the result, so the activity of catalase in an extract from yeast cells. We have a 5-marker table. Really, these are honestly easy marks. 1 mark for what? The pH heading, the independent variable heading, and has to come before the dependent variable. Well, I'm not sure if it has to, but ideally it would. 2nd mark for the dependent variable heading, and having no units in the table, no units. Your units should be stated in the header, seconds, pH doesn't have units, and never again in the table. You have a mark for 2 pH results, and then a mark for accuracy, so the time taken for pH 3 should be longer than the time taken for pH 7, and your results recording to the nearest whole second, because the device you are using, in this case, would not be giving any values to the nearest 0.1 seconds, for example. So accuracy matters. Easy mark here. What's the independent variable? Source of error, so you could say bead size varies because that's what the experiment was about. But yeah, stuff like that. Here it's asked for how you'd carry out a modified procedure. This is a common question and it depends. So if we're investigating the effect of concentrations, we know that you can use a dilution series, and also mentioning something that you would not change as well, because if we're changing something, we can't change 2 things at once, or that otherwise we're not really able to differentiate between what is actually producing the result and what is not. Okay, so they produced a graph here, and the question I wanted to cover was this one. It's asked us for the constant of lactase. So the formula for this is you really just need to find the x value at the maximum rate divided by 2, or half the maximum rate. So what you need to do is you have to look at your look at your graph, find where the maximum rate is. If you follow it along, you get to 9. What is half of 9? 4.5. What is the x value produced at that? 18. So what is your answer? 18. Simple as that. Now, why is it a 3 marker? Where do you get the 3 marks from? 1 mark is for showing the Vmax. 1 mark is showing half the Vmax, or half the rate. And 1 mark is for producing the answer of 18. Also, they may give you like a diagram and tell you to talk about observable differences between the leaf section in one part and the leaf section in another part. So usually, you could take a look at both images and differentiate between the two. But sometimes there are cases where not all the differences are that visible, but if you have a xerophytic plant and a non-xerophytic plant, you know what is present in xerophytic plants. You know what features they have. So even if you can't quite see it and you run out of things to say, you could just say things that you have already been taught about them, for example. Okay, now this is the last question I wanted to do for this paper, and that is calculations in regards to images and magnifications, okay? So if you're given a tiny bar like this, and in this case we're told to calculate the length of structure X. So first of all, you need to measure your bar length, which I've denoted as LSB. Let's say it was 5 centimeters or millimeters, I guess. Let's say it was 5 millimeters, okay? So if 5 millimeters represents 430 micrometers, we take the length of the actual cross-section, Li, and let's say we found that it was 15 millimeters. If 5 millimeters equals 430 micrometers, how many micrometers does 15 millimeters equate to? So we use cross multiplication, and then we end up with 15 times 430 divide 5, and we end up with 1,290 micrometers. By the way, this is a made-up value, but it's just an example to show you what you would do in this case. And the last thing I quickly wanted to cover was percentage change. This is the 2024 May-June paper 31 CIE-AS biology paper, and they produced a table, and really they took potatoes, put them in sucrose concentrations, sucrose solutions of course, and they measured the mass before and after. And really here they've asked us to obtain the percentage change in the mass of a potato piece that was soaked in 0.2 moles per decimeters cubed in trial 3. We go back to our table, specified our concentration. Here's our trial 3, initial 2.3, final 2.4 grams. So what we would do is we just take our final minus our initial over our initial. So 2.4 minus 2.3 divided by 2.3 times 100. So this is the change, and we times by 100 to get a percentage, and there are no units for that, okay? And then whatever we produce is our answer, and it's a 1 marker. It's a really easy 1 marker, so just be aware of this formula. And that is all